Alright, so in part 2 of our geometry revision, we're going to do a couple of little proofs, and a few of you... Let's have a look at this though. It says, prove that triangle PST, still very rude. Some of you don't understand the word respect. What can you tell me about the angle of Q and the angle of T? So can you say that the angle of Q is equal to the angle of T? Okay, very good. Now, what about, now it says that this is, what does this mean? It's like saying similar, isn't it? And you can also use a little tilde as well. So I just want you to think about that. What about angle P? What can you tell me about angle P? Isn't angle P equal to angle P? Aren't they shared? They're shared angles. So this angle here is the same for both. They both have a 90-degree angle. So doesn't that mean that the other angle is also equal? Yes? Well, also another thing as well is that this angle here, this angle here must also equal this angle here because we've got a 90-degree angle and the same angle. So what we can say is that A, so therefore we've just proven that these are similar. Does it make sense? Now you don't always have the same angles as such. As in you can't always prove the same angles. Now it says if triangle PST is the object, triangle PRQ is the image, then TS is equal to X centimetres and QR is equal to, so TS is equal to X centimetres. So let's call that an X, and QR is equal to 3X. Okay, what is the scale factor from this? Now, let's have a look at it, where if I was to go and get this triangle and flip it around, you can see there that this angle here is actually going to be equal to this angle here. Was that correct? Yeah? So how, if you think about it then, that means that this length here is actually similar to this length here. So then what's the scale factor, or what is the scale factor? 3. Pretty straightforward, isn't it? Okay, now the way you need to see it is we've got that triangle. This triangle has to be sort of flipped around this way, if you like, this triangle here. And you can see that angle there is X, and this, where is it? What have we done? We've done flip that around, and then that is going to be S, that's going to be T, and that's going to be P. All right, if PR is 6Y centimetres in length, PR is 6Y centimetres in length. So then state the length of PS. So think about it. If PR and PS are like the same sort of triangles, same sides, just different, then if PR is the bigger one, and that's 6Y, what would I have to divide that by to get the length of PS? 3.
What, 3?
Because the scale factor is 3. We've just done that scale factor here. Sorry?
How do we know that PS is equal to?
Just because when we draw the triangles, they're similar. We have to remember that PS, the length PS, is equivalent to the length of, because of these angles are joined to this thing here. So PS and PR are similar. Okay, so if we're told that PR is 6Y, then PS must therefore be 3. Just wait a sec. No, they're not. But look, let's have a look at this. Let's have a look at this. This angle here and this angle here, these need to join up. Now, they're different angles. Okay, look at that. That line segment between those two angles. What about the line segment between the same two angles? That means that those two sides, or those, because we know that these triangles are similar, then PS must be similar to the length PR. Okay, look. Is it joining the right angle triangle? No, it's not. Okay, so we're looking at this length here and this length here. Okay, so similarly then, what about this angle here? ST here would be similar to what? Wouldn't it be similar to QR?
But they're not the same size.
They're not the same size because there's a scale factor.
Yeah, but they don't even look the same. Like, as in, like, one's on an angle, one's not.
But haven't we just proven that they're similar because all angles are the same?
Yeah, but that side isn't like 3 times bigger than that side.
Yes, it
running
is.
along the bottom, and PS is like looks like the hypotenuse. I don't understand how they're similar.
We've flipped the triangle over. We'll get to it. We'll have a look more of it. I just want to continue on with this just for now. All right. Calculate the length of the PQ. What's the length of PQ then? If I've got that. This is PT. What's PT? PT's 2y. Is it? Or no. So we want to find the length of PQ. Okay, so the length of PQ. Now, length of PQ is what? Well, I guess we could use Pythagoras' theorem. Have we found PR? Isn't PR like 2y? But PR, if PR is 6y, yep, so PR is 6y. So we've got 6y squared. And what are we subtracting away? Like we've got that 6y squared, but what about this side here? What's that? That's 3x, isn't it? Yeah, we've already found the length of QR. QR is 3x, or we've been told.
What does that arrow mean?
Subtract 3x, all squared.
Oh, okay.
Now it says calculate the length of PQ, but I don't think we can really do anything more than that, can we?
Why is it square rooted?
Well, because it's... Why is it the square root? Because... All right, so can we go ahead and find it now? Well, 6y squared, so just using Pythagoras, this is where this is coming from. Okay, a squared plus b squared equals c squared. And I've just rearranged that to say that, and like so, and then we've got that is the square root of 36y squared minus 9x squared. But do we know what x and y are? I don't think we do. So,
Wait, don't we get rid of the squared thing? Isn't it just 36y minus 9x?
no, because this was PQ squared is equal to that. So there is equal to that. So so yeah, it's PQ is equal to. So we've got the length of PQ is equal to that.
No, when you do this, why do you have the
All right, just resuming that. Shh. So yeah, we've got to leave this in terms of x and y's. I don't think we can work that out. Can't work it out. Shh. All right.
So are we just going to skip that one?
Yeah. Well, we really that's it. That's the answer. Now, let's have a look at this one. Complete these steps, and we're looking at proofs, and that's what a lot of people were whinging about. That saying they didn't know. We touched on it last semester, so it doesn't really surprise me as to why we need a bit of work on this. What can you tell me about the angle CED? Can you tell me about the angle CED? It's the same as AEB, isn't it? So the angle CED, right, this angle in here, is also the equivalent of angle AEB. Because they're... Why though?
Because they have
Supplementary.
What's the word?
Supplementary.
Are they supplementary? Are they...
I don't get
oh,
that.
I feel like 360.
Yeah, is there a list
That's
of these
right.
words somewhere?
They're vertically opposite. They're vertically opposite. Now, what about CDE? What about CDE? If I call angle CDE, what might that angle be the same as?
ABE.
Angle ABE. Well done. ABE. Why? Because they are...
Z. I don't know what that is.
It's alternate. Thank you. CDE. So angle CDE is equal to angle ABE because they are alternate. And let's have a look at it. Let's do a little Z. Ooh.
So the first angle, EN. That
Alternate.
is vertically opposite.
Vertically opposite. Yep. That's exactly right. So they're vertically opposite. Now what about DC? What's the length of DC? DC is equal to AB. Now, what have I just proven? I've proven two angles and a side. So therefore, we can say that angle, side, and
Mr. Underwood,
we've now proven it.
could you also because you could do the Z backwards, do you understand what I'm saying?
Yeah, of course you can. So let's have a look and prove that it says here, hence prove that AE equals CE. Well, if triangle ABE is similar, now I like to do it this way, is similar to triangle CDE, then what can you say about what are corresponding sides? What's AE similar to? AE must be equal to...
George just said that.
What? What's corresponding side to AE? CE. And so they're what we call corresponding.
Isn't that just exactly what it says in the question? Like, I don't understand how writing ADE is.
It's going to prove it.
Yeah, well, we've got to prove it though. That's what.
Is that
Yep. And what about BE? What's corresponding to BE? Is equal to DE. Oh, well, yeah, no, it's okay. I'd say DE. Yeah, BE and DE. No. Corresponding sides as well. Corresponding sides. Okay, good. So therefore, what can you tell me about these triangles? Don't their diagonals intersect? The diagonals bisect. And we've now just proven it. Nah, that's all right. So what's that? Side, side. Side, side. Angle?
What does that even mean, sir? Diagonals bisect?
These diagonals.
So how do you find out those sides?
These diagonals bisect. Okay.
How do you figure out the sides?
Well, that's a side. That's a side. And that's an angle. When they bisect. If they bisect, they're going to have the same angle. Okay. I know it's tricky stuff.
I just like when there's more numbers than like.
Are there any circular theorem stuff in this? All right. Shh. Now I'm going to stop there, and